We now discuss the solution of a problem from the section Differential Calculus. And the given problem is based on the number of real solutions of a polynomial equation of 7th degree. This question has appeared in the joint entrance examination main held on 28th June 2022 in the first shift. The given question is the number of real solutions of x to the power of 7 plus 5x cube plus 3x plus 1 is equal to 0 is equal to. We are given 4 options. Option A 0, option B 1, option C 3, option D 5. Required to find the number of real solutions of this equation. We now discuss the solution of the problem in detail. We are asked to find the number of real solutions of this equation x power 7 plus 5x cube plus 3x plus 1 is equal to 0. Let f of x is equal to x to the power of 7 plus 5x cube plus 3x plus 1. You note that f of x is continuous in the whole of the real, on the whole of the real line, that is minus infinity to plus infinity. Why it is continuous on the whole of the real number line? Because it is a polynomial. And we notice that the value of f at minus 1, substitute x is equal to minus 1 in this and simplify, we will get minus 8, which is negative. And you also notice that the value of f at 0 is 1, which is greater than 0. So f of minus 1 is negative, f of 0 is greater than 0, fx is continuous, then you recall a theorem, which is an application of the intermediate value theorem. This is the theorem. If a function f of x is continuous on the closed and bounded interval a comma b, and f of a multiplied by f of b is negative, that means f of a and f of b have opposite signs like this, then there exists a point c in the open interval a to b such that f of c is equal to 0. That means to say that the equation f of x is equal to 0 has a real solution in the open interval a to b. So apply this theorem. Fx is continuous, f of minus 1 is negative, f of 0 is positive, therefore their product is negative. Therefore apply this, then f of x is equal to 0 has a root, has a solution, has a real solution in the interval, open interval minus 1 to 0. So this gives guarantee that there will be at least one real solution in this interval. Agreed. Now we want to talk about the increasing and decreasing nature of this function. For that we take its first derivative. F prime x is equal to differentiate 7x to the power of 6 plus 15x square plus 3 greater than 0. And observe that this is positive. This is greater than 0 for all x belongs to minus infinity plus infinity. That means for every real number x, f prime x is positive because it has all even powers of x and there is a plus 3. Therefore, it will give rise to, f prime x will give rise to greater than 0 for every real value of x. So now apply your first derivative test. Then what it says? It says fx is strictly increasing function in the whole of the real numbered line, that is minus infinity to plus infinity. Now combine this 1 and 2. fx is strictly increasing on the whole of the real number line, and fx has a root in the -1 to 0. Because it is strictly increasing function, it will not cross the x-axis more than once. It crosses f of x, the graph of f of x crosses the x-axis somewhere in the open interval -1 to 0. That means it has a real solution. Because it is strictly increasing, it will not cross again. So it will cross exactly once. Therefore, it has exactly one real solution. So now 1 and 2 will imply fx is equal to 0 has exactly one real solution. So let's look at our options. Our answer, it has f of x is equal to 0 has exactly one real solution, tallies with option B. Therefore, the answer to this question is option B. That means it has exactly one real solution. That is the detailed discussion of the solution of the problem on the number of real solutions of a given 7th degree polynomial equation from the section Differential Calculus, and I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.